Okay, so apologies that we're running a few minutes late. We had a couple of technical hurdles that we've managed to climb over, so slight stress levels have been through the roof, but we're there now. So I'm going to keep my bit to a minimum. I'm just going to say thank you so much for coming to the 21st London Accessibility Meetup. Happy Christmas. Woohoo. We have two amazing speakers and amazing talks today. We've got Léonie talking about accessibility mechanics, and then we've got Ruby and Will speaking about voice interfaces and a project that they worked on for the big live fix. But I'm going to hand over straight to Léonie, who's going to talk to you about accessibility mechanics.
Great, thank you, Al. Good evening, my turn to check now. Is everyone able to hear me okay? Yeah. Awesome. So it's entirely my fault that we are late starting. One of the dangers of trying to do a talk using a screen reader with a talk that features screen reader demos, and not wanting to put you through the pain of listening to mine, whilst ensuring that you can hear the bits that I do want you to hear. So thank you for your patience. This evening, I'm going to talk about the need for us, particularly as developers, to be time travelers when it comes to accessibility, and in particular, accessibility mechanics. We've got nearly 20 years of accessibility on the web behind us, and there are things from the past, the present, that we can draw on and need to draw on, and also things that are coming in the future that we need to be aware of, we need to feed into, add our opinions and our comments as they start to take shape, because almost certainly they will become part of our future in the products that we build. Browsers will be a familiar thing to all of you, I'm sure, particularly for the moment these four browser engines, WebKit, Edge HTML, Chromium, and Gecko, that are mostly represented in Firefox, Chrome, Edge browser, and Safari browser. I say for the moment because if you haven't heard, Microsoft has just announced it's going to stop developing Edge HTML and switch over the Edge browser to using the Chromium engine. So we're going to lose a quarter of our browser engine ecosystem, which is somewhat worrying for those of us who lived through this website was designed for IE6, best viewed at 480 pixels. But anyway, I digress, that's not a topic for today. But browsers have a very close relationship with assistive technologies, and in particular, screen readers. Again, if you're not familiar, a screen reader is a piece of software that sits on pretty much every operating system available now. On Windows, there's the proprietary screen reader JAWS. There's also an open source free screen reader called NVDA, and a free integrated screen reader called Narrator. On Apple products, both iOS and macOS, you have an integrated free screen reader called VoiceOver. On Linux, there is another free open source screen reader called Orca. And also on Android, there is the TalkBack screen reader. So there's good choice when it comes to screen readers. The reason I want to talk to you about this particular relationship between these two applications, the screen reader and the browser, is because it's absolutely critical to the accessibility of content on the web for screen reader users. Oops, sorry, here we go. So in the past, let's start our journey there. In the late 1990s, there were only screen readers for Windows. They were all proprietary. There was a screen reader for the Mac operating system, but they stopped producing it. It was a third-party application. They stopped producing it in about 1997. So for the best part of a decade, Windows was the only choice for screen reader users. And what used to happen when we loaded an HTML document into the browser is that the browser would take the document and it would go off and it would parse the HTML. It would create the document object model, the DOM, that we are aware of as scripters and coders. It would also create the graphical view of the HTML, the bits we can see on screen. It would apply some browser-specific styling to give some of those things like headings and form fields a visual representation. And it would provide interactivity where that was necessary. So you can type into edit fields, you can press buttons, all of those kind of things. The screen reader used to come along and do exactly the same thing, but completely separately. So it would pass the HTML document and it would create its own virtual model or virtual buffer of the page. And the browser and the screen reader did this without really having anything to do with each other. So we had two applications taking the HTML and creating representations of it suited to their particular audiences. Now, it doesn't take a genius to figure out that's not the most efficient way to be doing things, and it's also not the best way to be doing things, because when two different people take the same thing and look at it with their own perspectives or their own opinions, what generally happens is that you end up with two largely separate interpretations of the thing, and that's not very useful from anybody's point of view. So again, if you're not familiar with a screen reader, what this enabled people to do from the sort of 1990s onwards with the web was to read text a little bit like this.
Heading level 1 using the ARIA current attribute posted in link code things on January 14th, 2017. It is common on the web for the current thing in a collection to be highlighted visually, but providing an alternative for screen reader users has often involved something of a hack. The link ARIA current attribute is intended to solve this problem.
So it was great because it was possible to access content, but it was a little bit laborious because reading web pages was very much like reading a text document. You had to start at the top of the page and read until you found the bit that you were really interested in, and then, well, keep reading. This gave rise in part to the idea that assistive technology users and screen reader users in particular need longer to interact with web pages and other applications. That might have been true back in the day. It's most certainly not true now. And part of it is because we don't tend to listen at the speed most other people can find a screen reader intelligible at. This is my screen reader reading that same clip, for example.
Heading level 1 using the ARIA current attribute posted in link code things on January 14th, 2017. It is common on the web for the current thing in a collection to be highlighted visually, but providing an alternative for screen reader users has often involved something of a hack. The link ARIA current attribute is intended to solve this problem. Heading level 2 common.
So, like most other human beings, screen reader users are not known for their patience. We dash through content pretty much like sighted people scan through it visually. We have ways and means of speeding up the whole process. By the time we get to the early 2000s, things had changed quite radically in the relationship between browsers and screen readers. The browsers had implemented support for platform accessibility APIs, and that meant that screen readers could ask the browser for accessibility information about the content. So the browser really took on the job of doing all the heavy lifting, and the screen reader just had to come along and say to the browser, now you've taken that HTML and you've done your DOM representation and your graphical representation, tell me what you know about the accessibility representation of this content. And that structure is known as the accessibility tree. By the mid-2000s, we also had voiceover on the screen on the scene from Apple. So again, there was more choice here as well with this change in environment for the relationship between the two pieces of software. Like browsers and screen readers, there are platform accessibility APIs available on every operating system. In the desktop arena, there are 3 platform accessibility APIs on Windows. There's one for macOS, another for iOS, another for Linux, and if you look at the mobile space, Android has its own too. These are not APIs as we recognize them as developers. They are only usable by assistive technology applications. So we can't JavaScript them, we can't use them to ask the browser for accessibility information. Only an assistive technology like a screen reader can do that. And what happens is that when HTML is loaded into the browser creates its accessibility tree of all the content. The screen reader comes along and sends a message through the platform accessibility API and says, hey, this element on the page, what can you tell me about it? What purpose does it have? How do I refer to it? Does it have a name? What state is it in? Tell me all the information. So we see things like this becoming possible. If we take the HTML5 main element, it's there to mark up the main content area of the page. And in the accessibility tree, we will see that it has a role of main. That's its purpose. It's to mark up the main area. Beyond that, it doesn't have much accessibility information available about it. But a screen reader will ask the browser for the information and use that to say something like this to the user.
Main region.
Main region. So as someone who can't see they're at the start of the main content area, the screen reader just tells them that's where they are. It's also a useful navigational hook. Some screen readers let you jump straight to the start of the main element if it's present on a page. And so you've got a quick way of getting straight to the meat of the page. The nav element is another example. If we look in the accessibility tree, it has a role of navigation. And again, the screen reader can use that information.
Navigation region.
It becomes very simple. And again, you can navigate to navigation regions as well as the main region. So this not only gives you an indication as to what part of the page you're on and what its purpose is, it also gives you a quick way to navigate between high-level chunks on every page, the equivalent, if you like, of glancing at a page as a whole and taking in its kind of relative different sections. The browser also does useful things with things like lists. So we take an ordered list and 3 steps inside it. The browser will not only make the information available that this thing has a role of list and the things inside it have roles of list items, it'll count up the number of list items inside the OL element and make that information available to the screen reader when it asks to.
List of 3 items. 1 do this. 2 do that. 3 do something else. List end.
And all this is just provided courtesy of the browser because of the information in the HTML. It works for headings. So, for example, in this case, we can see that the H1 element has a role of heading. It also has an additional property that's made available. It's level, in this case, a level 1 heading.
Heading level 1.
And that information gets used by screen readers to know something of the hierarchy of content on the page. Heading level 2, followed by heading level 3, gives you a sense that there's a main section on the page, followed by a subsection, and inside it, further subsections again. So really useful information if you can't take the page in at a glance. It also works on all kinds of form fields. So for example, with a checkbox, it can tell you based on the type what kind of form field it is, and also based on its checked attribute state, what state it's in. So there's lots of accessibility information made available about it. Lastly, if you associate the form field with a label using the ID and 4 attributes with the same value, that gives the form field an accessible name. It tells the screen reader how to refer to this checkbox when it's telling the user what kind of thing they're dealing with. So we get something like this.
I live in the UK checkbox not checked. Checked.
So I live in the UK was the label provided through the label element. That's how the screen reader knew how to refer to this particular checkbox. And we understood when someone had come along and checked it because its state had changed. The browser made that information available to the screen reader, and the screen reader told the user. So it all connects together pretty efficiently under the hood. We can take a button element as a good example of this. If we look at it, it has a role of button. In this particular case, we'll assume it's a play button, perhaps for a media player of some description. So the text inside the button gives it an accessible name. It tells the screen reader how to refer to this particular button. And that means that when we interact with it, the screen reader gets some information.
Play button.
So it took the accessible name and said that it was a button, and the user's quite well aware that they're dealing with a button. For those of you looking at that slide, you might have noticed that there is a missing piece of the puzzle though. That button was toggled while the video was playing, but there was no announcement of that by the screen reader. That is something we can fix though, which brings us on to the present and our current situation. We have come into an era now in the past perhaps 10 years where we create custom UI controls and components. We take divs and spans mostly as building blocks, and we try to create things that don't exist in HTML. Tabs and tab panels are a probably really easy example of something that there are no HTML elements to use, so we have to create them for ourselves using JavaScript for functionality, CSS for styles, but we're going to be missing some accessibility information. This is also the case because JavaScript frameworks, they all, unfortunately, have a bit of a nasty tendency to decide that a span is far better than an anchor element, even when the span itself is going to be a link. Don't get me started on that, but the reality of it is that we have to deal with these situations. The accessibility problem is that div and span elements are effectively meaningless in accessibility terms. They don't have a particular role, they don't have a particular state, you can't interact with them, the browser doesn't provide any form of interaction, mouse support, keyboard support, none of it. So even though we could take some divs and spans and we could style them to look like, say, a 2-button toolbar with a bold and an italic button in it, we could use JavaScript to make it function like a toolbar. When a screen reader comes across this collection of divs and spans, unfortunately all they're going to hear is this.
Bold. Italic.
Just 2 pieces of plain text, because there's no accessibility information anywhere near this particular custom-made component. The good news is that we can do something about that. We can use ARIA, Accessible Rich Internet Applications, to polyfill some of the missing accessibility information. ARIA 1.1 is the current version. It was released earlier this year. They're already working at W3C on ARIA 1.2. But as it stands, there are more than 70 different roles that you can apply to elements like divs and spans. You use the role equals attribute, and then you choose a value depending on what accessibility role you want to fill in. There are lots and lots of them. Pretty much every component you can think of has a role value in ARIA. Buttons, checkboxes, radios, radio buttons, radio groups, sliders, toolbars, progress bars, trees, grids, tables, and so on. Like I say, 70 odd different values. So if you're using a div and a span to pretend to be something else, then you need to use the role attribute to fill in that missing accessibility information. There are also 45 ARIA prefixed attributes, ARIA-something, and these are the attributes you can use to fill in things like missing property information. So ARIA level, if you were faking a heading, for example, with a value of 1, 2, 3, 4, 5, 6. You can also use these properties to inform about the state of something. So ARIA expanded, if you're building a disclosure widget and you want to tell a screen reader user when it's open or closed, for example. There are lots of these that can be used to, again, fill in more of the accessibility blanks. So if we take this truly appalling example on screen of a span that is about to pretend it's a button, so we just have a span, and we'll take the play button example that we looked at before. Right now, as this stands, as I say, no accessibility information in a span element. It's inert, you can't interact with it, you can't focus on it with the keyboard because the browser doesn't think it has to do anything with a span element. It can just sit there and sort of look good, I guess. So we can use the role attribute with a value of button on the span, and in the accessibility tree that the browser creates when it sees this HTML, screen readers, when they ask, will now find out that this thing is a button. Still won't behave like a button. We can style it to look like a button, but at the moment it's still just a span pretending in the accessibility tree to be a button. We can use tab index with 0 to start fixing some of the keyboard support. Tab index 0 will make it focusable, so someone who's using a keyboard can tab onto it now, which is a good first step when you actually want to do something with a button. This also means that speech recognition tools will be able to focus on it with much the same result. They'll be able to actually start interacting with the button. We do need to provide the interaction. Mouse interaction is usually the first thing people think about, so we can just add a mouse click event listener. But we also need to make sure that, like a native button, someone who uses a keyboard can hit the space or enter keys to make the thing active. So we listen out for the key codes 13 and 32 in some JavaScript, and when we detect either of those being pressed, we get the button to go ahead and do whatever it is it's supposed to do in life. Oops, sorry. So then we end up with a button that, to all intents and purposes, looks and behaves and reacts more or less like the native button.
Play button.
We're still missing that important piece of information, though. How do we let the screen reader user know when they've actually pressed the button or not? We use one of the ARIA prefixed attributes, and it won't come as much of a surprise, I'm sure, to know that it's ARIA-pressed. We can set that initially to false, which will do several things. It will change the role of the button to toggle button. So as soon as a screen reader asks for information about this now, they'll be told it's a toggle button rather than a standard button. And its current state will be in a not pressed state. We can then add some functionality in, and when someone now hits the button, what we'll do is we will change the value of the ARIA pressed attribute. We'll change it from false to true. i.e. we change the button state from not pressed to pressed. So in the accessibility tree, this information is now available for a screen reader to go ahead and grab. We can do something even more useful. This is a tip I picked up from my friend and colleague Hayden Pickering, which is to tie the visual style of the button to the states of the ARIA pressed attribute. So only when the ARIA pressed attribute changes from false to true do we change the CSS that changes the visual appearance of the button to look as though the button has been pressed. It's not a showstopper, it's not even really necessary, but it's a really useful way of making sure that your accessibility is working. Because if your accessibility isn't working and you've tied your visuals to it, You'll know about it sure enough, because when someone comes along and presses or clicks on the button, the visuals won't change as you expect them to. And you know the first place to go looking for a problem is probably in your accessibility code. So it's a helpful debugging tool and a slight simplification of the code, if you like. It is worth noting, oh, hang on, no, wait, sorry, and then we can see a demo, sorry, yes.
Play toggle button not pressed. Pressed. Not pressed.
And so now we've got all the information we need. A screen reader user asked the browser for information about the button. They were told it's a toggle button called play. When they hit the button, they were told it was pressed, and when they hit it again, told it was not pressed. And so suddenly we've joined up all the dots to create a much more complete experience for someone using a screen reader. I will point out, though, that starting off with this bound as a button is a really, 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 really bad idea. So just using the button element with the aria pressed attribute on it is a far safer way to go about it. And if you're a little bit lazy, like me as a developer, it's a much better way to go about it, because you don't need to add in all that extra JavaScript. You don't need to add in all the extra attributes for tab index and the role and other bits and pieces. So it simplifies your code, and it simplifies your testing, because the fewer moving parts that you've got in your code, the less likely things are to break when you start testing them. We're also in the present at the time now where we're starting to see custom elements appear on the scene. I was talking to the team at British Gas very recently, and they've just relaunched their homepage, and it entirely consists of custom elements and web components. If you're not familiar with this idea, it's that we can take existing HTML elements and we can change or extend them, or even completely invent new ones. So we could, for example, take our button example, extend the HTML button element in HTML and create a new element called toggle-button. Custom elements always have to have a hyphen or a dash in the middle of the name somewhere to distinguish them from actual, quote, proper HTML elements, unquote. So in this case, we'll create a toggle button that wherever we use it will create the button that we've just seen, our toggle button for our media device, for example. We just create the custom element, and inside the constructor we set things up. Custom elements use something called a shadow root, and that's because custom elements work very much like, elements like the video element. So we just use video, source equals something, close the video element. Yet when that's represented on the screen, there's a whole bunch of buttons and sliders that the browser makes visually appear and presents them on screen for use. If you inspect the code, if you look at the DOM, you won't find any of those buttons and sliders and other bits and pieces. And that's because they're all contained in something known as the shadow DOM. It's all terribly Jedi, but that's the name they give to it. It's things that you can interact with, things that are displayed on screen, but when you inspect the code underneath, they're apparently not there. And custom elements work in very much the same way. So we use a shadow root as the starting point for our element. And then basically, in this particular example, I've just thrown all the code in from the previous example for our toggle button. I've used the worst of the examples, added in all the tab index and ARIA attributes and other bits and pieces. So the code is exactly the same. It's just tucked inside a custom element constructor. What this means is now, as a developer, I could go to my page and write open toggle button, put play in the middle of it, and then close toggle button. And that's all I would need to do in the HTML. It's very, very simple and very, very clean. Now, this is just a button example, but you can imagine doing something like this, say, for a set of tab panels. So instead of having to use divs and spans or lists and section elements and a whole bunch of ARIA and other bits and pieces of attributes, you could actually simplify this to create, say, a tab group element that contained tab elements that were associated with panel elements, for example. So it's a very neat way of simplifying your code. And if we do this, when we play this and we use our toggle button, again, the experience is remarkably familiar.
Play toggle button not pressed. Pressed. Not pressed.
There is one slight catch with this, though. And that's when we currently go and look at our toggle button in the code. When I said that you'd see most things wouldn't be there, they're all in the shadow DOM, there is one exception. At the moment, custom elements leak accessibility. So where we've applied the ARIA pressed attribute inside our custom element, when we use the toggle button element in our code, the ARIA pressed attribute is still being applied there. And so, again, with one attribute, that's not really the end of the world. But when it comes to adding a lot of accessibility attributes into your custom element, it starts to get very untidy. In a custom element, everything otherwise is encapsulated. All the styles are encapsulated, so they don't leak out. All the functionality is encapsulated, so they don't leak out. But right now, accessibility does sort of spill out sideways into the main document that you use your custom element in. And that's not ideal, especially for engineers who tend to like things to be neat and tidy. Ooh. So that brings us to the future. There are people thinking about how to solve this leaky accessibility problem in web components and custom elements, and also ways that we can, as developers, use accessibility and access the accessibility tree in the browser more easily. And the answer is in something called the Accessibility Object Model, or AOM. It's being developed by people from Mozilla and Google and Apple. And it has 4 phases, and if it comes into being properly, it will be a JavaScript API that we can use as developers to ask the browser to give up its accessibility information. In other words, we'll be able to talk to the accessibility tree in the browser just like the assistive technologies can. I will say if it comes to fruition. The team working on this already came up with version 1 and it introduced something called an accessibility node. They then scrapped that because they decided it wasn't really a sustainable way to do things. So they're currently right back at the drawing boards. So as of this moment, there is no support for anything in the AOM, but they're very, very committed to working on it, which is why I want to talk to you about it today, because this very much comes into the category of things that we all now need to be feeding into to make sure that they get it right when they do. So phase 1A of the AOM will do something very simple and very useful. It will enable us to use element and attribute reflection when we're applying accessibility attributes. So at the moment, if you say apply a role in your JavaScript to an element like our span earlier, you'll have to write something like, let's assume our button element, we've grabbed it and we're using button as a variable. So you'll have to do button.set attribute, open parens, quote role, close quote, comma, then the attribute value, so in this case, quote button, close quote, close parentheses, semicolon. And it's a little bit long-winded, and it's not how most people write JavaScript for other attributes in HTML. So what this phase 1 will do is let us write simpler code that's much more familiar and much more similar to the way we treat other attributes in HTML. You'll just be able to say button.role equals button. So it becomes simpler and much more familiar. Phase 1B will also let us set accessibility properties on elements when the element is first created in the page in the accessibility tree. But interestingly, they'll also let us change accessibility characteristics in response to user interaction. That's something that isn't possible at the moment. So when, for example, a user comes along and hits our button, in theory, with the AOM, what we'll be able to do is have the JavaScript listen for that button press, the same way we listen for key presses at the moment, and change the accessibility characteristics in response to that particular event. They're going to add some user events to make this more feasible, particularly on mobile platforms. So things that will let us do increment up, increment or decrement down. In swipe gestures, this is really hard at the moment. It's very hard to make that properly accessible if you're writing a custom element for use on mobile, because there aren't really any events, interaction events at the moment that equate to that. So they're going to add a few of these into it to make response to user interaction a lot easier and more straightforward. Then we get on to the slightly more interesting and perilous bits of the AOM. It will be possible to add things into the accessibility tree. So up until now, the browser is the only thing that can actually create or put things into the accessibility tree. With phase 3, this will all change. It'll be possible for us to come and add virtual nodes into the accessibility tree. On the one hand, part of me is incredibly excited by this, because I hate doing things like hiding text using CSS just to leave a little bit of helpful information for a screen reader user. Because I know that sooner or later someone who doesn't use my style sheets will come along and be presented with all that helpful information they really didn't need to see. So the idea of being able to add information into the accessibility tree just for the benefit of a screen reader user does have a certain appeal. I'm also curious about VR and accessibility. At the moment, VR on the web just operates inside the Canvas element. If any of you ever explored Canvas when it was first released, all the visuals that appear on screen are just there in JavaScript. There are no elements other than the parent canvas element, and VR is very much the same. So one possibility of being able to add things to the accessibility tree is that we can create an accessible representation of the objects that are inside a web virtual reality. Now, I have no idea whether that would be feasible in practice, but the idea is an interesting one, and it's a possible use case for this part of the AOM. Lastly, the last phase will enable us as developers to walk the entire accessibility tree from top to bottom. So in the same way that we walk the DOM now to find out, give me a list of all the elements, all the anchor elements in a page, for example. With the accessibility tree walkthrough, we'll be able to do things like, give me all the elements on the page that are headings. And that will enable us to create functionality that will enable navigation by headings, for example. Now, screen readers do that pretty happily of their own accord at the moment, but keyboard users, for example, do not. So it opens up all kinds of possibilities for letting people navigate through content in different ways. We have to be aware, though, of laws of unintended consequences. And this is the one particular area where I think the AOM team really needs input from the rest of the world. There's a trade-off between accessibility and privacy. Once we make it possible for developers, for websites, for content to be able to interact and access the accessibility tree, we give website owners, content producers, with absolute clarity, the knowledge that the person using their website at that moment in time is a screen reader user. The reason it's that specific is because the browser only creates the accessibility tree when it knows an assistive technology is running. ARIA is only really supported by screen reader users, and the AOM is almost entirely based on the use of ARIA. So as soon as we start using it, we'll give away an incredibly personal level of information about the person consuming the content at the time. One school of thought at the moment is that the browsers can pop up a permissions notice. There's a bit of a trend at the moment with browsers to say, well, we'll just ask the user if they're okay with this and shovel all responsibility onto the person who wants to use the website. And I can pretty much guarantee what will happen if this goes ahead. You'll get a little pop-up on the thing that says, this website would like to know that you are using a screen reader. This is being done in order to make this more accessible an experience for you. Is that okay? And of course, most people are going to go, sure. What they may not think about is that if there is advertising running in an iframe on that website, that iframe could be doing exactly the same thing. And we all know how trustworthy advertisers are with our personal information. So just imagine if you went to a website and because of an advert displayed in an iframe on that website that you largely ignored at the time, they grabbed information about you and says, hey, the person on the end of this IP address is actually blind or using a screen reader for another reason. And the next time you went back to that website, you suddenly started seeing all sorts of, quote, blind-oriented advertising for whatever anybody else might think that would look like. But that's a pretty dangerous territory to get into. And so we need to really think about the privacy question with the AOM before it gets too much further. It can't be stressed. It's one of those things that once we start down a path, we'll never be able to close it down again. So we've got to get it right the first time. And privacy, at least in my opinion, as a user and an engineer, is too much of a trade-off for the level of accessibility and return. But that's a conversation we all need to have. So that takes me to the end, and our need to be time travelers as we think about accessibility. There's an awful lot of accessibility information that we get from the past, from using HTML in the way it was first intended to be used. We shift a whole load of the heavy lifting onto the browser, the keyboard interaction, mouse interaction, a degree of visual rendering, but heaps and heaps of accessibility information that we don't have to do anything to provide. But we've got to recognize that we don't live in a world where we always have that luxury anymore. We do have to use JavaScript frameworks, often with good reason. They have plenty of beneficial things about them. Sometimes there just aren't things in HTML and we want to create them. That's fine too. We shouldn't constrain our imagination. And that's when we need to look to the present and using ARIA to understand what we need to polyfill in terms of accessibility. We also need to look at the implications as we start to see more and more web components and custom elements coming online to make sure that all the accessibility is baked in properly into them. And then lastly, we need to travel to the future, and we need to keep an eye on what's coming our way before it gets there, and we need to feed into that process so that by the time the future is here, we can be as sure as we can be that we've made all the right decisions, or at least made the best decisions that we can based on the information we've got available. So please, whatever else you take from this talk this evening, go away, be a time traveler in terms of accessibility. Pull the best from the past, the present, and the future. Thank you very much.
Questions? Put your hand up if you have one, and I will bring you the mic. Over here.
It's all gone quiet, said Rhubarb.
Try again, I'll try to get the attention. Is that not working? Oh. Can you pass it now? Come on. Yep. Try again.
Hello?
Hey.
Yeah, cool. Hey. Yeah, I was wondering if you have any suggestions in terms of CSS grid and levels in terms of heading first and paragraph later. Because the trend I'm seeing is that lots of people, well, businesses are asking, oh, can we have this paragraph before the heading, for example? And in terms of grid, it's very easy to change the order of elements arbitrarily, and it doesn't always match with the semantic headings and components in general.
Yes, that one's a growing challenge. In some respects, we've used CSS for a long time to play a little bit fast and loose with that. We've quite often, actually not so much these days, but going back a few years, it was quite common to see the source order of the page ordered such that the content area came first and the navigation area afterwards. But visually, it followed the more traditional layout convention of having navigation on the left or across the top. So we've sort of been doing this for a few years, but the advent of grid, Flexbox and other things have certainly made life a bit more interesting. For screen reader users, the really important thing is the source order. So if you put a paragraph before a heading, I can pretty much guarantee you I will never know that paragraph belongs to that heading. It's just utterly illogical. I'll navigate to the heading and then I'll carry on reading down the page from there. So I'll either think your content is is kind of a bit strange or just I've missed it. But either way, the experience won't be that useful, unfortunately. That's where you can use things like grid to reorder it. So visually, it makes more sense to have the paragraph before the heading. You can do it if you absolutely have to. I'd be quite curious to see the results of some just bog standard usability testing on that, though, because for the most part, certainly in the West, we expect content to be one thing after another, top to bottom, left to right. So yeah, my hunch is that actually paragraph before headings is not necessarily the most usable thing for anybody. The danger of reordering visually, but not in the source order, is when you're using interactive elements, because then you'll really start to make things complicated for sighted keyboard users, because they'll tab through the page and the tab sequence will have nothing to do with the visual appearance, and so they won't know where their next tab key press is going to take them. So weigh up the pros and cons. If you don't have to, that's the ideal. If somebody's really, really pushing you, suggest to them that it might not be the most usable thing for any of their consumers. If they're still going for it, rearrange a little bit, but if you're rearranging interactive elements, then that's probably the point to draw the line at, I think.
Next question. So we've probably got 5 minutes worth of questions, just there.
Thanks, it's Grant from Léonie.
Thank you.
I was just wondering whether you've got any preference for a JavaScript framework, whether you'd be able to give any recommendations if you were to recommend any to our customers. And I don't know whether you'd be able to say, but are there any that you'd avoid?
I cheerfully avoid a lot of them, but that's not a practical answer. So the one I'm most likely to recommend at the moment is React, not because natively itself it's particularly better than any of the others, but a friend and ex-colleague of mine, Carl Groves, has a company called Tenon, and they have just released Tenon UI, which is an accessible React component library. So if your teams are using React, then teaming that up with Tenon UI is a pretty good way to start patching up some of the accessibility in a reasonably painless way. So that at the moment kind of puts it ahead of the game for kind of ease and convenience. Bootstrap isn't bad. There are a number of people contributing to the accessibility of that, so that has some reasonable accessibility involved. If I really was going to avoid anyone at all, I think it would probably be Angular. There are some accessibility measures that you can take. There's ng-aria, which you can drop in to patch up some of the, or polyfill some of the accessibility. The reason I mostly avoid Angular, though, is that if none of those things help and you find yourself needing to patch up the accessibility yourself, trying to find the actual element inside an Angular thing that's responsible for the bit you need to change is a ridiculously time-consuming task, because stuff's just buried inside divs, inside spans, inside more divs, inside more spans. So yeah, if I had to avoid one, that would probably be it. Welcome.
Any more questions?
Hi. Time traveling to the past. Well, we had lots of development practices before ARIA was available, and HTML5 elements like main and nav and so forth came along. So, for example, some of us are still persisting with some of these practices, like creating a little menu of skip links and the like. Are those things actually counterproductive, or just they don't help anymore, but they don't do any harm?
Yes and no. So skip links, as in a one link at the top of the page that says skip me to the main area, the main content, is still extremely useful, because actually screen reader users en masse tend not to use them, because we've always had other ways of navigating. Heading is now the main element in some cases. But for keyboard users who don't use an assistive technology, skip links are still incredibly useful. What isn't so useful for anybody is having, as you said, a little menu of skip links, because the idea of a skip link is you jump over all the navigational links and other claptrap at the top of the page to get to the bit you actually want to be looking at or interacting with. So there's a sort of irony when you see kind of a list of 8 or 9 skip links, because you sort of, in giving people lots of skip opportunities, you've reintroduced the problem you were trying to avoid in the first place, which is having someone tab through umpteen links to get where they needed to go. So used once or twice wisely, they're still very, very important for the moment. If we could persuade the browsers to implement keyboard navigation for things like the main element, that would go away. And in fact, Matthew, are you here? Yeah. My colleague at TPG, Matthew Atkinson here, you've written a plugin which provides keyboard support for landmarks, things like main elements and other bits and pieces. So there is support out there, but if we could persuade the browsers to do it, that would be a real game changer, I think.
Time for one last question. You take it as far away as possible.
Where's the coffee? That's an important question.
I'll quickly formulate my question. So I think it's possibly a little bit naive, and it might be one to catch up with you afterwards, because I'm not a developer, but
right.
I get the impression that we're spending a lot of time with trying to make JavaScript accessible, and what we, at least from a naive point of view maybe, is that we had something that seemed to be accessible, which was HTML5, and I'm just trying to work out if I understood correctly that putting all our energies into creating new HTML5 elements or making that more accessible is a waste of time when the floodgates of JavaScript have already been opened. And is that a summarization? Or?
Yes, you're right. You get a lot of free accessibility when you use HTML. The JavaScript floodgates have already opened. And they've been open, for maybe 10, 15 years now. You may remember sort of, phrases like Ajax and Web 2.0 from, the early 2000s. Yeah. That's when we really started inventing things. And I think that's a core part of the web. We don't ever want to stop ourselves from trying to invent new stuff. The problem we've got now is that what used to happen is that, somebody come up with a bright idea like, we need a checkbox element. And we'd write it into HTML, and then the browsers would come along and say, yep, brilliant idea, we'll implement support for that. what we're finding now is a huge amount of reluctance from the browsers to implement anything new. HTML5 was the last time we saw them try to do this, and even things like, say, details and summary, it's a terrific idea. It massively simplified the custom code we needed to provide a disclosure widget. But even that, there was enormous reluctance. I think Edge, even now, doesn't support it properly. And so, we could really use a set of tab panel type elements, because we see the damn things all over the internet, but the browsers are just not interested in providing kind of minting new HTML elements to do the job for us. Which means we've got to keep doing it with the JavaScript and divs and spans route, which, yeah, you're right, it means a ridiculous amount of time and effort. But that's it, unfortunately.
Real world. Thank you.
Yeah, and it's not a naive question. There are no such thing.
Okay, thank you.
Brilliant. Can you put your hands together and say a massive thank you to Léonie?
Thank you. Merry Christmas, everyone.
So we're going to have a 25-minute break. We're going to get you back here for about 8:15. There should be more drinks left. There's actually some mince pies. Could you put them out? Or there's Did everybody that wanted a mince pie get a mince pie? Yeah. Anybody not get a mince pie?
Make a wish if it was your first mince pie of the year.
Any wishes made?
No?
I didn't even know that was a thing.
Put your hands up if you've seen The Big Life Fix. Cool. So I, hand on heart, say that The Big Life Fix is one of, if not my favourite programme on TV. So I was over the moon when Ruby agreed to speak the first time about one of the projects on The Big Life Fix. Was that in April, I think it was?
March. Yeah.
So I'm super excited that you're back to talk with Bill about one of the other amazing projects, which is to do with voice accessibility. So over to Ruby and to Will.
Thank you.
Yeah, hi guys. I'm very much a bit part in the show, but I did work on it, and we're just here to talk to you today about accessibility for voice UIs. So, yeah, my name's Will Merrill. I'm an industrial designer by training, so I make physical products. I design physical products, be it from deodorant cans to autonomous vehicles. That's the kind of thing I work on, and this is my colleague Ruby.
Hi. Yeah, my name's Ruby Steele. I'm a senior design strategist at Smart Design. I also am a service designer, an experience designer, and BBC Two fixer, I guess, for those that have seen the show. And my background is really in understanding people, so I do a lot of design research and going into homes and getting to the kind of, the crux of the matter with people.
And yeah, so we work for a design consultancy called Smart Design, based over in Shoreditch. We've also got an office in New York, but we're a design consultancy, so a lot of clients come to us, and we really like to kind of market ourselves as putting a human perspective on innovation. So we really like to focus in on what value we can bring to humans, and really look at what kind of pain points people are experiencing. So this is some of the projects we work on. So we do a lot of product to service projects. So looking at existing physical products and how can that be extended into more of a service ecosystem. Product to platform. So again, instead of selling an individual item at scale, how can we turn that into a platform which can maybe make a bigger impact to the world? We also look at how physical and digital worlds combine. So that's kind of how me and Ruby interact with each other. I tend to look at more of the physical world, and with the service design Ruby brings, we kind of look at how the physical and digital start to interact and start to create a kind of a better world for everyone. And also product evolution. So our heritage is in product design, kitchenware. OXO was one of our original products, which we'll talk about later, but we also often kind of evolve current products and make them better for people. I'm here to talk to you today about voice. So why voice, why now? You probably all experienced the plethora of voice UI products on the market, from Amazon, the Echo, with Google Home Hub. Also Apple have their Apple, can't remember the name, but there's, especially with Christmas coming up, there's been a load of development in this area, and we've seen it before, the kind of the interface revolution. So back in the 50s, the push button was the real interface of choice, and it was applied to basically every single product. You can see here in the kitchen, you'd press a button to turn on the lights, but there'd also be a button next to that to start the taps. And you can kind of see that maybe isn't the most applicable nowadays, and you start to see these fads fade out, and you really get to the kind of the really important, the kind of the crucial elements. And again, that's kind of happened with screens. So a few years ago, you design a product, and a client would often say, but where can we put the screen on this device? And really, it only really makes sense for a key number of situations. And I think we're going through the same kind of thing with voice. So again, clients are saying, how can we get voice into this? And it's applying voice to stuff that maybe doesn't need voice. And I think we're getting to that point where we're starting to really find where we can add value by incorporating voice into our products. Smart Design was founded in the 1980s by our CEO, David Stowell, and along with that, he kind of pioneered the idea of inclusive design. I'm sure you're all aware of what inclusive design is, but I'm just going to give you a bit of a crash course about what that might mean. So for us, we think you can learn a lot when designing for the extremes. So I'm sure you've all seen the famous bell curve before. So OXO was founded back in the 1980s with Sam Farber here. So he approached Davin back in the 1980s and said, we've got an issue here. We have these products in the kitchen and people just can't use them. He experienced this firsthand through his wife, Betsy, who was in the kitchen making an apple pie. And she was peeling an apple and she just couldn't use the peeler. I think we've got an example of it here. So you probably all experienced this before. And for most people, this works pretty well. It's you kind of get by and it works pretty well. But for Betsy, who had chronic arthritis, it really just didn't work for her. And Sam Farber thought things needed to change. So here's the bell curve. So what Davin and the Smart Design team decided to do was to look at the extremes of users. So most people kind of fit in the middle, kind of the average. They've got kind of average ability. They're not professional chefs, but they don't suffer from arthritis, and the kind of products tend to work relatively okay for them. But what David and the team decided to do was to look at arthritis sufferers for one extreme, so someone who found dexterity to be a real issue, and then also look at the other end and look at pro chefs, so people who really needed the performance of this product to work really well. And they argued by looking at both of these types of people, you could design a product which would actually work for everyone much better than the existing products would. And so that's what they did, and they came up with the hopefully now famous OXO peeler. It's been entered into the MoMA, so it's now in the permanent exhibit at the MoMA, and it just recently won a Lifetime Design Award from Dezeen, I think, possibly, or Fasco. Anyway,
Fasco.
And so yeah, that turned into a global business with thousands of products now on the market, and it's all come from this idea of inclusive design, designing for a larger proportion of people to try and make products for everyone much, much better. And I'm going to pass you over to Susan to introduce you to Ruby to introduce you to Susan.
Almost. Yeah, I think when I last came to talk at the accessibility meetup, I was talking about designing for the extremes, and I had this hypothesis at the beginning, which was designing for the extremes makes better experiences for everyone. And I think that Big Life Fix is a really good example of where that is true. So I think I'm going to kind of pose that again. You know, if you design for the extremes, do you make better experiences for everyone? And Susan was certainly an extreme. She was one of the people that we worked with on the show. So I've actually done 5 projects now with Big Life Fix, and Susan was the final one that I did. It was a bit of a special case because Smart Design actually did it with me, and so rather than working on the project kind of alongside my day-to-day job, we actually did it intensely for 4 weeks, and we had a team working with us, which I'll introduce you to in a bit. But the point was, you know, it's a really interesting way of designing when you take one person that's in a really extreme circumstance and almost just kind of concentrate on one end of the bell curve to see whether you can create something that will be better for everyone. So Susan is 65 years old, and she's been living with MS for over 25 years. So she's got progressive MS, multiple sclerosis, which affects like pretty much every aspect of her life. Where it sort of started with sort of mild symptoms, it got progressively worse over time, and she's now in a situation where she's not able to walk. She's in a wheelchair. The dexterity in her hands is very poor, so she's not able to grip very well. I'll come back to that. She has carers come into her home 4 times a day, so she has 2 carers that come in 4 times a day and do everything for her. So she's not actually able to sit up for herself. She needs help doing that and getting dressed and washing and eating and all the things that a lot of people take for granted. This is a little kind of important bit of information about Susan that makes more sense later on, which is that she absolutely loves owls. She used to be very involved with the Girl Guides, whose the kind of mascot is an owl, if you will. So she has millions of them all around her house. I didn't even bother to count, but there were a lot. So that was something that we would like you to sort of pay attention to. She's an absolutely wonderful woman. She's really articulate and funny, very well read, but she was basically becoming more and more kind of enclosed and, you know, and trapped because of her own disability. So the start of the process was to go in and spend time with Susan, see what her life was like day to day. So we were there as the carers came in and sort of went through a day in the life like you would in any kind of design process, and were able to map out the different pain points. So her home is fitted with some devices to help her control things, but they were really kind of left wanting. You can kind of see here, this is an illustration of the kind of dexterity she has in her hand. This is the control for her wheelchair, and it does work fairly well because she can push this lever, but those buttons are actually really, really difficult for her to press. One of the things that she was using was something called the possum. Are people familiar with this device? I think it's quite old. Basically the way that it works is it connects to lots of other devices in her home, her TV, her telephone, some of the lights and things like that. And it uses this menu in order to make those things work, basically. And she has this switch strapped to her leg that the carers will need to add strapped to her leg every day. And what she needs to do is when she wants to, for example, turn on the TV, she needs to scroll through every single one of these items to wait until she gets to the thing that she wants to do, and then she presses it. So it's reading it out, and she has to wait until she, you know, gets to the thing that she wants to do. So that's really slow and very easy to miss, actually, because she knows what she wants to do with her head, but her hand might not react fast enough. Also, this was how she would answer the phone. So the phone would ring, and she has to scroll through like BBC One, Channel 4, etc., to get to answer call. It was just, you can see how it came to be, because it was clever in the way that it could bring lots of devices into her, you know, into allowing her to use them, but just very, very slow and very painful. And actually, there was a time that we were there when the phone rang, and I was kind of waiting to see what happened, and it rang and rang, and she was trying to answer it but missed it. And I said, were you intending to answer that call? And she was just like, well, yeah, but you know, I can't do it fast enough, so you know, this is just the way that it works. And she was an incredibly patient woman. She'd sort of just come to terms with her situation and got used to it, rather than because there wasn't really a huge amount of option for her. Equally, you know, if she wanted to have something on the TV, what would usually happen is a carer would put the channel on that she wanted to watch, but then she would just have to stay watching that until the carers came back, because the effort of trying to change the channel was just too much. Yeah, she was really, really kind of sweet about it, but for us, we just felt like in this day and age, that's totally ridiculous that anyone needs to live like that when the rest of us are doing about 15 different things at once. We're watching TV, we're listening to this, we're doing that, and why is it that she can't even do the most basic things? So as a kind of, you know, design consultancy, and we're sort of always thinking about all the different kinds of new technology, you know, voice UIs seemed like an obvious answer for her. So, you know, it's something that doesn't require pressing any buttons, it doesn't require anything too difficult, so why couldn't, and we know that it can also connect to all the things that she might want to control in her house, like the TV and the lights, and even making and receiving phone calls. So why isn't that the answer? Well, we took various products in for her to use. The Amazon Echo, or the Alexa, it's the interface, and the Google Home, and we sort of said, right, okay, we've connected these to different things, why don't you have a go? Now the problem is these have been designed for not people like Susan. They've been designed for the like super tech savvy people that are super used to technology and all the things that they can do, rather than thinking about how someone who, I mean, effectively she's kind of been left behind by technology. She hasn't been able to use a computer or a mobile phone or anything like that in many, many years. So she doesn't even have like a mental map of the kinds of things it can do, let alone know how to interface with it. One of the problems with her MS is the fact that, especially as it gets later in the day, it starts to affect her cognitive ability. So even though she's an incredibly intelligent woman, it starts to slow her mind down. So for example, she describes it as having these foggy moments where we've actually all experienced it, where you know the word you want to say, but you just can't think of it. But that happens to her a lot. Now, if you're going to work with something like the Alexa, you need to know what you're going to say. So when we put them in front of her, what we found was actually really upsetting, because it kept failing on her. It kept timing out. It kept she would start to speak to it, and if she paused for too long, it would get fed up and move on. And I remember she was just kind of, she was getting really frustrated and kind of embarrassed, and she was saying, "Oh, I'm sorry, it's my fault. It's because I'm stupid." And we were trying to say, it's not because you're stupid, it's these products that are failing you. They haven't been designed to work for you. So, if you look at them, I mean, why would anyone want to talk to it, really? It's like a big black thing. It doesn't have anything that makes you feel like you should talk to it. It's actually quite intimidating. But she certainly didn't even really understand that she was supposed to be speaking to it. When we were working on the project, we kept using the metaphor of, for these products, as being like going into a really snooty restaurant where the waiter comes over and just expects you to know exactly what you want without showing you the menu, without telling you what it is that you're actually able to do. And you have to say exactly what it is. And if you don't say it fast enough, they'll walk off and you have to call them back to make your order. And essentially what we wanted to do was, make the Alexa more accessible for Susan. So, the Alexa is an incredibly amazing product. It can connect to many, many different things, and it did all the hardware. It did all the things that we wanted to do. It was just the voice UI that was failing. That was the part that we needed to make. We kind of needed to make this like accessibility jacket for it. If we just go back to our bell curve here, it's almost like we were kind of, the Alexa has already been designed for the early adopter, so it's already kind of started to accommodate some of that criteria that very tech-savvy people have. But where they've not done such a great job is understanding the kind of tech excluded, or anyone that has any kind of temporary impairment like Susan does. It's worth pointing out at this point that, to even for any product or any service that's ever being designed, it's just kind of really flawed to think that, designing for someone like Susan is the exception, because, okay, fine, she's permanently impaired, temporarily, sometimes even more so with this kind of when she gets more tired, but we're all impaired at some point. Whether it's like we're driving, that means that our eyes are being, occupied and we're kind of visually impaired. Or, we can be dexterously impaired if we're just carrying a load of shopping and we're trying to do something. Or, cognitively impaired if we're walking down the street and lots of things are happening. So actually, interfaces need to design for that for everyone, not just the people who are in a permanent state. So like I said, this was a slightly different project to the other projects on Big Life Fix, in the sense that we had a team working on it for a certain amount of time. So I'm just going to introduce you to teams. So we had a very multidisciplinary team. It was a really interesting challenge. So there was myself, who's a kind of like design strategist and experienced designer. We have Sam Roots here, who is a coder. He's actually here in the audience, so I'm just going to embarrass him just for a moment. We obviously have Will, and then we had our tech director from New York, and Jasper, who is an interaction designer. The reason I'd also like to just point out, we did this in 4 weeks, so it really was quite an intense kind of sprint-like process where we were being very experimental and we were being quite ambitious with what we wanted to do, but also just bear that in mind when you realise how hacky it actually was when we came to the solution. So one of the things that we wanted, before we kind of show you what the solution was, we thought it'd be really valuable to kind of pull out our 3 key learnings about designing for voice, because we kind of came up with these 3 principles that we realised about, especially when designing accessibility for voice UI. So I'm going to pass back over to Will at this point to tell you about those 3.
Yeah, so like Ruby said, it was an amazing project, but I think with every project you should often try and reflect and think about what learnings you can take forward to any other project you might do. So in this case, we came up with 3 principles we think that most, if not all, people could incorporate into a voice UI project. The first one being personalize the content. So this is the Alexa skill store. So a skill being to Alexa as apps are to the iPhone. And there are currently, I think there are maybe 15,000 skills on the skill store. And most of those have 0 ratings and just aren't used. And that's because there is this opacity to the device. You just can't see what it can do. There's no real way of knowing its capabilities. And for us, and for Susan, she, let alone being, she was not familiar with voice UI. She was not really familiar with smartphones. So this concept of communicating with a bit of technology verbally was very, very alien to her. So what we wanted to do was to really strip out a lot of the chaff and just present her with the content that had real value for her. And we also felt that you can see how this isn't quite working. When I was at university, we were often taught if you designed a product and you had to design an instruction manual to go alongside it, you weren't doing a very good job of explaining how that product worked. And you can see that with a lot of voice UIs. All of them have, when we bought the Amazon Echo and we looked at the box, you could see the whole side of the box was telling you different ways you could interact with the product. And we thought that wasn't really the best way of doing it because it felt like it wasn't very intuitive. We think there are examples out there where personalization is done very well. I'm sure you're all familiar with Spotify, but they're basically an algorithm company. They are host music, but their real USP is the power of their algorithms, being able to create very personalized playlists for their users out of a catalog of millions of songs. And that's all done via personalizing the content, understanding the user's likes and dislikes, putting it through an algorithm and presenting them with music that they think you will like. So we don't have the power, the brain power or the manpower of Spotify to do that for Susan. So we went for a much more analog approach by talking to her and asking her what she liked. And by doing that, we could kind of take it from being this snooty waiter kind of analog and move it towards being more of your local waiter, your family restaurant around the corner who knew what you liked, what you didn't like, saw you every day, could recommend suggestions based on your previous preferences, and really make it a much more familiar and friendly product to interact with. Rule number 2 is use semiotics. So we need to give signals and feedback. We need to present her with wayfinding points along the way to let her know that she is saying the right things, doing the right things, and in the right point in the navigation tree. As a product designer, it's quite easy to do because you've got a lot of things to play with. So I think this is a really great example. You look at this and you immediately know what it is. It's a pair of scissors. But kind of why do you know it's a pair of scissors and how do you know how to use it? So you kind of look at it and you think, well, there's 2 holes there and it looks kind of like finger shaped. You probably put your fingers in there. And then there's a bit of metal at the end and it looks kind of sharp, so it probably cuts things. And you can kind of start to figure out how this product might work just by looking at it. But with voice UI, you have none of that. It's really opaque, especially with these current ones, which kind of just sit there and wait for your response. So what we wanted to do was try and bring some of these kind of visual semiotics and turn it into more of an audio semiotic to give her kind of waypoints and guidance along the way. So Here's an example of where feedback doesn't really work out very well. So the Santander bikes, the Boris bikes, when they were launched, they all had a keypad to unlock the bike, and you were given a code, you pressed in the code, that unlocked the bike and you could cycle away. But about a month after these being installed, you could go along and look at these keypads, and it looked like they'd all been vandalized. They'd been scratched, they'd been broken. And that wasn't because there was some person going along and breaking them, it was because there was no feedback. When you pressed the buttons, there was no visual feedback, so there was no lights, there was nothing to tell you that you'd pressed the button. There was no tactile feedback, so the buttons, there was no kind of depression, there was no movement within the keys, and there was no audio feedback. It made no sound. So people didn't know that they were inputting the codes, they couldn't tell. And that created this frustration, and people resorted to using keys and anything they could find to try and enter the keypad. When they turned into Santander bikes, they updated it with just a simple bit of code to present a bit of audio and visual feedback, and it stopped happening. Another point I'd like to talk about, I think this is a really great example of how you can have a rule which then evolves over time and maybe stops being as valid. With voice UI being such a nascent technology, I think you've got to work a lot harder as a designer to explain to the user how this product works. So you can see this with the app icons and how they were designed when the iPhone was first released versus the equivalent logo now. So this is the YouTube app icon, and you can see back when the iPhone was launched, they went for a very, very analog visual representation of the app. So they went for a television, not even a modern television. This is like a TV from the 50s. But they felt they needed to do that so that people could understand when they pressed that app, they were going to experience visual content. It's a media provider. They were going to provide media, much like televisions did in the 50s. And nowadays, they've gone a lot more abstract, but I'd argue that they could only do that by going through these steps. So they couldn't have gone with this straight away in the first iteration of the iPhone, because people wouldn't have understood what the app did. Only by going through these stages could they get to this point now. And we want to do something similar for Susan. So at the end of it, what we wanted to do was we wanted to say to Susan, we wanted the product to say to Susan, firstly, I've heard you. Secondly, I understood you. And then thirdly, here's what you need to do next. So it means that she's never going to get lost along the way. And the third kind of key takeaway we'd like to talk about today is humanizing the technology. So as Ruby kind of hinted at earlier, you look at this product and it really doesn't say much. It doesn't really say that this is a product that you talk to. It could possibly pass as being a speaker. There are some kind of speaker grills. So you can see maybe it makes a sound, but there's not really anything else that tells you it's something that you talk to. If anything, it's quite foreboding. It's probably more appropriate on the Death Star. You know, it's like a cold black cylinder. It doesn't really feel very friendly or something you want to have a kind of a human conversation with. I want to take it a step further. So this is Hal from A Space Odyssey. And just by looking at this, you probably come to expect you would interact with it in a certain way. So you'd probably expect it to be quite kind of functional interaction. So maybe you'd talk to it in a very logical way. Maybe it would be a series of instructions. You probably think it was quite an intelligent being, maybe a bit aggressive, possibly. And I'd like you to compare that with this. So the voice could be exactly the same, the software could be exactly the same, but if you just skinned it with two different faces, you'd expect to speak to it in a very different way. So if this was the kind of the face of your voice UI, how would you expect to speak with that? It would probably be maybe a lot more friendly. You'd maybe think it was a bit more approachable, something that you would maybe feel like it would give you a bit more leniency if you were to go wrong, possibly. And we wanted to maybe try and incorporate that into into the kind of the visual representation that Susan would be interacting with.
For those that can't see, this is the emojis that are used in the iOS app. So it's kind of like little animal faces. There's a unicorn and a monkey and a cat and a robot. But they're kind of deliberately cutesy and friendly looking.
Yes, thanks, Ruby. So yeah, I'm going to pass you back to Ruby, who will pass you back to...
Smooth transitions. So yeah, we'd now like to introduce you to Susan's owl. Hence the owl reference at the beginning. It wasn't a completely random selection. It was something that she particularly finds, appealing and friendly. And we basically followed those three principles. So we created a menu for her that allowed her to know where she was. It was kind of like a conversation tree. We kind of packaged it in this owl, in an owl form that she it changed the way that she spoke to it. And we also personalized the content. So we kind of took away all the needless stuff and just left her with the things that she wanted to do. So we've got a short video to show you.
There's all sorts of things that I can't do now because of the effects of the MS.
Susan has 2 carers that come in 4 times a day to do absolutely everything for her. She hasn't got the power to do anything for herself. They wash her, they dress her, they help feed her. To Susan, that's what the reality is. So if she thinks that she wants to reach out to her daughter because she's having a bad day, she can't do it. And it's hugely isolating for her.
The MS affects my eyesight, so now I cannot read. My hands shake constantly. I cannot get the words out that I know I want to say.
Most technology is designed for the masses. You aren't going to be able to interface with technology in the same way that other people can.
At Smart, we strongly believe in the practice of inclusive design to design things that work better for a wider range of people and to really try and combat products that stigmatize certain groups of people.
When Smart Design got involved with BBC Two's Big Life Fix television series, we needed an entirely new approach to voice UI to create her very own voice-controlled assistant in the form of her favourite animal, an owl.
Okay, lovely Susan, what would you like to do?
Voice control is still in its infancy, and for users with accessibility needs, it can be rather frustrating and unhelpful. Susan's MS causes what she describes as foggy moments, where she cannot think of a word that she needs to say. But voice control technology currently demands that you say exactly what it wants to hear in a certain time.
So the design we created for Susan was, in layman's terms, a kind of accessibility jacket. It's like a wrapper around that core Amazon Alexa service, and it provides access to someone in Susan's position.
Alexa, open my special menu.
Okay, lovely Susan, what would you like to do?
The massive advantage of voice is it gets around her physical limitations. She doesn't have to press anything, she doesn't have to hold anything. But where it fails is in its ability to meet her cognitive needs.
People need a lot more than just the words you say. They need visual cues and gestures to help understand what's being said. But that's missing with a lot of these home hubs like Amazon and Google Home. So for Susan, we wanted to give her something which connected with her more emotionally. So we created an owl which was patient, it gave her time to think, and it allowed her to feel more connected to the technology.
The ultimate goal for the menu was to create a situation for Susan to lead her along the way. So for example, if she wants to listen to music, the beginning part of the navigation is, do you want to listen to something, watch something, or call someone?
Listen to something.
Okay, Yippee, let's listen to something. Pick which you would like to do. Music, books, radio.
We gave the ability for her to really just kind of give one-word answers, so she didn't really have to remember anything.
Music.
Yes, good idea. Some music would be nice. What shall we listen to? Last played. Genres. Surprise me. Do something else.
Genres.
Okay, pick your favorite. 60s. Musicals. Country.
60s.
Play 60s playlist.
Watching Susan interact with the menu for the first time and watching her giggle.
As soon as she started talking to the owl, you could see that the interactions changed completely. She was much more engaged, she was much happier.
The owl gives Susan the freedom that the rest of us enjoy without even thinking. She's now able to make a phone call or play music or change the channel on the TV.
Thank you, Alexa.
Anytime.
So yeah, in summary, you know, we took an already quite brilliant product, but you know, made it accessible for Susan. There's kind of a whole other talk about how we managed to do this because it's actually very, very difficult. Although the Amazon platform is very open and it allows you to create skills as, like, even if you're not really a coder, you can just about create a skill. What it doesn't do is it doesn't allow you to have, so the menu itself was a skill, but that wasn't able to open another skill. So we had to do a few cheeky little workarounds, like basically at the end of a menu, kind of sort of path on the tree, it would then, we had a master dot that would have the menu on it, and it would tell the servant dot what to do. So it would spit out the kind of the outcome of that path on the tree was just the correct command for the Alexa to do what it needed to do. This was not the first iteration of trying to get this to work. We did it with a Raspberry Pi and something called Snowboy, which is kind of its own voice UI. That was horrendously bad and didn't work at all. And it was kind of like later in the game that we realized that we could actually have two dots talking to each other because you can actually have separate wake words for different dots. But that's sort of essentially how it works, and it kind of it meant that we weren't touching any kind of hardware. We were just creating something that allowed us to kind of help her navigate. So the other thing to point out is actually the owl itself is, as you can see, lit up to try and kind of exaggerate some of the existing interface that the Alexa actually has. So the owl will go blue when Alexa goes blue. So Susan knows that when the owl is blue, Alexa can hear her. It also, we wanted the owl to kind of feel like more of a presence in the room rather than the kind of foreboding black cylinder. We wanted the owl to kind of, it would kind of like breathe very softly, so the light would kind of go up and down just so that it kind of felt like there was something there. And it was all these little things that we did to try and help create this menu. And I think what we kind of concluded was, yes, this was about helping Susan, use this interface, but actually there's a lot of learnings there for voice UI in general because, kind of discoverability on these things is really poor, and even if you're the most, tech-savvy person in the world, you won't necessarily know, and something like a menu could be really, really helpful. And that is the end. Any questions?
Right, there it is. Any questions? Richard?
You talked about the problems of remembering words and delays and things. How did you actually deal with that side of things?
So the menu itself was designed to only require a one-word answer, and we tried lots of different things. We tried to make it more conversational because there's this instinct to think that conversation and computers and people is a good thing, but actually these menus and the skills themselves are very, very basic. It's not like talking to a human at all. It's like, well, it's dealing with a computer. So we had originally tried things like allowing her to say more in answer to Alexa, and kind of through iteration discovered that just asking her to say music was the kind of the base of what she needed to be able to do, and that helped her never have to hold too much information in her head. We also discovered things like it was actually quite difficult for her to remember where she was in the tree. So that's why the menu says things like, okay, lovely Susan, what would you like to do? Music. Yes, some music would be nice, because actually we found, especially when she was more tired, she could go down music, but then sort of hear the options and not associate it with music anymore. And so we kept having to kind of, it's all that kind of like audio semiotics thing that we were talking about. We were constantly trying to signal to her where she was in the menu so that she knew what to do next, and make that really simple. As far as the actual kind of pausing in the skill itself, there wasn't a huge amount of wiggle room. But whereas that would be a really nice, I think this is probably a question for Sam, but like to being able to extend the pause time as much as possible. But you know, there is a limit to that with Alexa.
Did you want to respond to that, or Sam? No?
Yeah.
Next question. Oh, over there.
Did you consider gaze interaction as a technology in the beginning?
We didn't really. Susan's eyesight was going, so we didn't really, even the owl form itself, she couldn't really see any of the detail, like the beak and the eyes and things, so we tried to keep that really simple and just focus on the voice. But I think one of the really interesting things about designing interface is that, you know, you should never really rely on one interface anyway. It's always going to be stronger if you can marry up, you know, visual and tangible and voice and listening and all those things together. So I think that's a really interesting, you know, addition to voice for sure.
Yeah.
Hi there. You kind of answered my question already in the previous question down here, because I was going to ask about how you thought this could apply to someone who has a speech impediment. I guess if you around the delays, it probably didn't help immediately. But kind of related, it looked like the sort of conversational piece was quite deep. Did you find any sort of limitation to that? I mean, probably it worked specifically for Susan, but was there any kind of element of frustration because it was so deep?
For Susan?
To get to what she actually wanted.
Yeah, absolutely. Do you want to answer?
Well, I think with the personalising the content kind of idea, what we wanted to do was to really limit how far down the tree you could go. So you present her with a top level choice, and then only go 2 or 3 deep, so that you didn't get too far down the rabbit hole and not really find a way back. Yeah, I don't know too much about speech impediment issues, but hopefully just by having the one-word responses, you didn't have to put too many words together, and it was, I'd hope that would also help. But I think it is worth saying that this was only a 4-week project, and it's really just scraping the surface of this. And yeah, there's a whole world out there of this is kind of like a stepping stone to going further into all of this, I think.
The Amazon Echo is actually really impressive when it comes to understanding what different people are saying, and it actually starts to learn your voice over time. So, because we did some testing with some other people with MS, and one of the women, the condition was really, really affecting her voice, and she spoke very quietly and very slowly, but it didn't actually have a problem. It was actually okay. So that's one of the things that Amazon's really nailed is, you know, being able to understand people, I think.
Thank you.
Any other questions?
So I was a great talk, and I really enjoyed that. Thank you. One of the things that was playing in my head was how soon you would be tempted to do usability testing with Susan, how much you were maybe holding back because getting frustrated with something she was already very experienced at. So putting her through, you know, your process of learning by what worked and what didn't work, and how often you tested what you'd come up with.
Interestingly, our kind of main challenge was the fact that we were making a TV show. So the TV show wanted to have this kind of big reveal, and that's actually something that was common across a lot of the projects. And that was really frustrating because we weren't supposed to test it. But with Susan, we were testing it over this 4-week process. Well, it ended up being kind of like 5 weeks. We were testing it once a week, as fast as we possibly could. We probably could have done with testing it more. And we actually would test it by just reading out scripts and pretending to be the system, just so that we didn't have to wait for the kind of the tech to catch up, because we kind of had these two work streams. We had the design, like the UX and the tech at the same time, and they didn't always marry up. But testing is definitely really important.
So kind of like how a UXer might, if they were designing an app, potentially get a lot of learning out of paper prototyping with someone.
Exactly.
You didn't actually
There's
have to do
so
the
much that
finished
you can
product.
do without having to actually build it, and especially with voice. You know, we have voices, so you can start playing around with it without touching any technology.
Thank you.
We've got time for one last very quick question. Marion, over there.
Hi, forgive me if this is very naive. I don't have an Alexa, and I don't know how the skills tool works, but is all this work that you did and all these skills that you developed, are they available for reuse?
Well, not yet. We've actually been asked this a few times. It's something that we could. It's not on the skill store. It's something we developed in-house, but using the Amazon Skill Builder. It's something, so anyone can build their own skills. So in theory, anyone can use this if they have access to the Skill Builder. It's just a case of buying 2 dots and installing our skill on one of them.
Can you put some instructions somewhere?
Yeah, absolutely. I mean, we've talked about this. We've talked about kind of open sourcing it and creating some kind of kit, like really, really simplified, so that you know, the dots are only £49 each, or maybe even less sometimes. They're really, really not that expensive. And so if you had 2 dots, and actually, that's a really interesting idea. We don't necessarily have to recreate the skill. We could almost tell other people how to recreate the skill, and then they can, you know, create the menu that they want to create and build it themselves. That's actually a really good idea.
Brilliant. Can you put your hands together and say a massive, massive thank you? Incredible work. Thank you so much. So we have reached the end of another meetup and almost end of 2018. Can I just say a big thank you to you all who keep coming to these meetups. We're really lucky in the quality of speakers that we get. We've again had 2 amazing talks today, so huge thank you to Léonie. And a huge thank you to Ruby and Will. I'd like to say a massive thank you to Sainsbury's, who have provided the event. They've helped us serve drinks and all those sorts of things, helped us with the audio. So yeah, massive thank you to Sainsbury's. Also, a huge thank you to Barclays. So Barclays have sponsored us and have helped to provide the food and the drink and the speech-to-text caption. So big thanks there. Again, huge thanks to Orla for the magnificent text-to-speech that she does. Who is because is this the first time that some people have seen live speech-to-text in action? Cool, yeah, no, it's incredible, so thank you very much. We'd also like to say a huge thank you to Meetup Video, who I believe we have successfully live streamed both videos with captions, which we've been trying for months to do, so this is really exciting. It got quite stressful, so again, apologies to Meetup Video and to Léonie. And yeah, we will be back next year. We don't have a date confirmed for January yet, but we will share that as soon as we've got it, and we will, yeah, we'll see you in the new year. Have a lovely Christmas and a Happy New Year.